This is section 3.1, part 4. We're going to be graphing quadratics again, but this time just by completing the square. And what we're going to do is take this function here, and that's what we had last time, but we're going to rewrite it so that we get some more information from it than just by leaving it in this form. So let's take the function, the expression, x squared plus 2x minus 5. And I want to end up with it looking something like this: a times x minus h squared plus k. You see, this is not in this kind of format, but I'm going to get it to that. So this is what I'm going to do. I'm going to take x squared plus 2x plus some perfect number. And that perfect number is going to make this into perfect binomials, which means I will have x minus a number squared. If I add that number in, I also have to take away that number because I don't have two sides of an equation. I only have an expression, minus 5. So I'm going to take x squared plus 2x. Now I need that perfect number so that when I factor, they come out identical. Well, to find that perfect number, you take half the middle term. So half of 2 is 1, and you square it. Then you take away that same number, because if you add it in, you got to take it away, because again, we're not adding to both sides because there's not two sides. And now that becomes x squared plus 2x plus 1. I can put it together as my perfect trinomial. Minus 1 minus 5 is minus 6. And this factors into x. If this is a plus, you look back and you put that in both of them. And I factor that into 1 and 1. So I get x plus 1 squared minus 6. Wow, in this form now, I will be able to tell what the vertex is. The vertex is always the opposite of this, which would be negative 1, and what the actual of this, negative 6. So we have, all right, so negative 1, negative 6, down here is my vertex. I also know how it opens, either up or down. I can tell because whatever number is in front, the a that's in front, if it's positive, then it opens up. If it's negative, it opens down. So this number in front is a positive 1, so I know that this quadratic is opening up. I just don't know how wide it is. But I can find out how wide it is if I know what the y-intercept is. Notice, if the y-intercept turns out to be this parabola is going to be pretty wide. But if the y-intercept turns out to be up here, it's pretty narrow. And then we can draw the matching side because it is symmetrical. All right, so we know it's going up. So let's look for the y-intercept. Always when you want to find the y-intercept, you set x equal to 0. So I can go back to the beginning. 0 squared plus 2 times 0 minus 5 is negative 5. So right here is my y-intercept. So now I know my parabola goes up like this and matching on the other side. If I were an artist, it would be matching. Okay, now I'm going to erase this and we're going to do another one. And practice getting it into the correct form, because using that, completing the square, making a perfect square, makes it easy to graph. All right, here we have 2x squared plus x minus 6 equals f of x. Well, first of all, to do this method, you can't have a number in front of the x squared. So I'm going to have to factor out a 2. So take 2 out of x squared. Now, 2 times some number gives me 1 in front of the x. Well, that number is 1/2. 2 times 1/2 x gives me x. And 2 times -3 gives me -6. Okay, so now I have to get the perfect square. X squared plus 1/2 x plus that perfect number minus that perfect number minus 3. Okay, so now perfect number. The perfect number always is half the middle term. Half of a half is a fourth squared. If I add a fourth squared, I have to take away a fourth squared. Okay, so now I have the perfect square. 2 x squared plus 1/2 x plus 1/4 squared, which is 1/16. And now I'm going to move this minus 1/4 squared. Notice there is a 2 being multiplied by it. So I have really minus 2 times 1/4 squared and minus 3 times 2. This 2 on the outside is multiplied by -1/4 and it's multiplied by -3. So I have a 2 in both of these. So this is 2, and make 2 parentheses, x plus plus. Turns out that 1/4 times 1/4 is 1/4 squared, and 1/4 x is the outside, 1/4 x is inside, 1/4 and 1/4 is 1/2. So this is minus 2 over 1 times 1 over 16 minus 6, which is 2 x plus 1/4 squared minus 2 times 1 over 1 times 16, 2/16, which reduces to 1/8 minus 6. 2 x plus 1/4 squared minus 6 and 1/8. So now, if I'm looking for the vertex, my vertex is the opposite, remember? So it's -1/4, -6 1/8. So if I was going to graph that over here, -1/4 and -6 1/8 be down here somewhere. Since the 2 in front is positive, I know it's opening up, okay? Okay, so this is 6 and 1/8. And here is -1/4. Barely. Okay? All right, so now if I want to know how wide it is, I got to find the y-intercept. So I'm going to go up here to the top where I have some space. Y-intercept, set x equal to 0. So I have 2 times 0 squared plus 0 minus 6. That's 0 plus 0 minus 6. You end up with -6, which is right here. Which means my parabola is going pretty wide. So it has to be wide on both sides. Okay, that is making a simple sketch using the completing the square method.